Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the change of base formula for logarithms. So the formula is here on your screen. What is this formula about? Well, it allows you, if you're working in one base, like log base C, to change the calculation so you're working in a different base, like log base A. We'll see in subsequent lessons this is really helpful when we do calculus, because the calculus of log base E is much simpler than the calculus of log any other base. It also allows us to prove some identities of logs and helps us with calculations like this. So they're the three reasons we want to use change of base. So how does change of base help with a calculation like this? Well, log base 2 of 5 is an irrational number. None of us would be able to do that off the top of our heads. So we need calculators. The problem is that many calculators don't allow you to do log base 2 calculations. They only allow log base 10 or log base E calculations. So if you have a calculator that doesn't allow you to input the base, but allows log base 10 calculations, we can use this change of base formula to come up with the answer. So what I'm going to do is change this calculation so it's log base 10. So this is how you use the change of base formula. So if I want to work in log base 10, I put log base 10 on the top and the bottom. Now on top goes the power, and on the bottom goes the original base. So these two numbers are equal. If my calculator doesn't allow me to do log base 2, I can just put this on my calculator and I will get the exact same answer. Similarly, I could easily change this to log base E. I would put log base E on the top and the bottom. On the top goes the power. On the bottom goes the original base. Each of these three things are equal, but this one you may not be able to put on your calculator. So that's where the change of base formula is really helpful. It ends up being about 2.32. So you can see we've changed a log base 2 calculation into log base 10 or log base E calculation. As I mentioned before, when we're doing things with calculus, working with log base E calculations will be much simpler. All right, let's try this question down here. So we've got log base M of N, log base M of P. What we want to do here is change the base so it's log base N. So, using the change of base formula, we're going to start with log base M on the top and the bottom. On top goes the power. On the bottom goes the original base. So, log base N of P will just be 8 over 32, which is a quarter. So what we've done is we've changed these log base M calculations to log base N. So very similar, if I wanted to find this, it would just be log base M, the original on top and bottom, and then the power goes on top and the original base on the bottom. So this would just be 32 over 8, which is equal to 4. So that's how you do questions like that, but this has allowed us to stumble on an identity. It turns out that log base A of B is just 1 over log base B of A, which is an important identity in logs. Now we're going to prove that formally in the exercises, but it highlights what I mentioned before, that the change of base formula allows us to prove things about logs. So now let's have a go at proving a logarithmic identity. So I'm going to use the change of base formula here to prove this identity. So the two identities have a different base, so straight away we should think about the change of base formula. So using the change of base formula, we would have the log 1 of b to the a. I'm going to write this as log base b. It would be log base b of power over log base b of original base. This is just the change of base formula here. So I can evaluate this very simply. The reason is that for any b greater than 0, b to the power of minus 1 is 1 over b. That's just a year 9 thing. So log base b of 1 over b, that is equal to minus 1. So I simply have log base 1 over b of a equals log b of a divided by minus 1. Of course, I can write that simply. I can just rub out the minus 1 and put it there, because timesing by minus 1 is the exact same as dividing by minus 1. And then I've easily proved this identity in 2 short steps. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.